This is Jessica.
This is Linda.
This is Crystal.
This is Devin.
This is Jason.
This is Wasima, aka Wawa.
That's Sahid. And we're group 12!
And our topic is the cerebellum and its relation to movement.
Cool.
Click.
I don't know when they get
What you see in front of you is a cartoon picture of the human brain. In the bottom right corner, you'll find the cerebellar hemisphere highlighted. The cerebellum is located at the bottom of the brain, with a large mass of the cerebral cortex above it and the portion of the brainstem called the pons in front of it.
The cerebellum is responsible for a number of functions. It is responsible for coordinating muscle activity, sequencing the motor activities, monitoring and making corrective adjustments in the activities initiated by other parts of the brain, and comparing the actual motor movements with the intended movements and making corrective changes.
Yeah, in addition to the functions of the mentioned cerebellum, it also has this function. It balances the eye movement control. It's also responsible for the axial movement of the neck, shoulders, and hips. It also functions in the motion of the distal limbs, especially the hands and feet. And it's also responsible for sequencing movements, timing, and coordination.
Jessica is going to demonstrate dysmetria. She's overshooting reaching of objects. Linda, touch your nose. Linda is demonstrating ataxia. This is characterized by uncoordinated movements.
They are demonstrating dysarthria.
How are you today?
Dysarthria is a failure of orderly progression in vocalization.
What you see here is a basic schematic of what actually happens in the human brain when you try to initiate some type of movement. So the cerebral cortex is going to send chemical messengers and neurotransmitters to both the basal ganglia and the cerebellum.
The cerebellum is responsible for sending excitatory signals to the cerebral cortex.
And the basal ganglia will send inhibitory signals to the cerebral cortex. Now what we're basically trying to say is the basal ganglia is for refined movements. So let's say me and Devin are just like shadow boxing, play boxing. If he wants to scare me, he's going to try to punch me in the face. But he doesn't want to hit me. And he'll stop right there because we're friends. He doesn't want to hurt me. But let's say his basal ganglia is messed up. So right now we're play boxing, and then all of a sudden he actually hits me. And that's because his basal ganglia can't tell his brain to actually stop.
Right, so put this in simpler terms, the cerebellum is responsible for me initiating the actual punch, but basal ganglia, again, is responsible for refined movement. It inhibits my actual hitting of his face.
Cool.
Hello, ladies and gentlemen. This is your brain. It is divided into 4 divisions: the prefrontal, the premotor and supplemental, the primary motor, and the somatosensory area. This is the caudate, the putamen, the globus pallidus, internal and external, the substantia nigra, the subthalamus, and the ventroanterior and ventrolateral nuclei of thalamus. We'll get into more detail in a second.
What you see in front of you is a diagram of the putamen circuit and the caudate circuit. Both of these are functions of the basal ganglia, which include the thalamus, the subthalamus, the substantia nigra, the caudate, the putamen, and the globus pallidus. 2 circuits of the putamen circuit are the primary putamen circuit and the ancillary putamen circuit. The third is the caudate circuit. And now, Crystal's going to demonstrate the primary putamen circuit. The primary putamen circuit mostly comes from the premotor, supplemental motor, and somatosensory cortex. And then it sends chemical signals to the putamen, which is highlighted in purple arrows. Next, it sends chemical signals to the globus pallidus, which is highlighted in green arrows. Thirdly, the globus pallidus sends chemical signals to the thalamus, which is highlighted in red arrows. Finally, the thalamus sends the signals back to the premotor and supplemental and the primary cortex for it to send signals to the motor neurons.
And now Jason will be showing the ancillary putamen circuit. From the premotor, supplemental motor, and somatosensory cortex, we have purple arrows going towards the putamen. Then, from the putamen, we have it going to the external globus pallidus, which is right next to the putamen, demonstrated in green arrows. From the external globus pallidus, we have it going to the substantia nigra and the subthalamus, demonstrated in red arrows. From the substantia nigra and the subthalamus, we have it going to the thalamus, demonstrated in blue arrows. From the thalamus, we have it going back to the premotor and supplemental and the primary motor, demonstrated again in purple arrows.
Back to your brain.
Go.
The last circuit is the caudate circuit, which involves part of the basal ganglia that has not been used until now. Most motor actions occur as a result of a sequence of thoughts. The caudate circuit is thought to play a role in the cognitive control of motor functions. Jessica will now come and show you the many different pathways of the caudate circuit. The caudate extends into all lobes of the cortex and receives a large input from all association areas of the cortex. It mostly projects to the internal globus pallidus, no fibers to the subthalamus or substantia nigra, to the thalamus, back to the prefrontal, premotor, and supplemental areas of your brain.
Crystal is demonstrating abnormalities in the motor functions of the basal ganglia.
Crystal, what is that?
I'm drawing.
I'm sorry, but that looks horrible. Can you please cut it up? You know what, Crystal, forget it. Can you just toss it in the garbage?
Okay.
The basal ganglia is responsible for control of complex patterns of motor activity. This includes writing, using scissors, shoveling dirt, some aspects of vocalization, and throwing balls.
Sahid is demonstrating chorea. It is flicking of movements of the hands, face, and shoulders.
Jason is exhibiting athetosis. Athetosis is defined as spontaneous movements of the hand, arm, neck, and face. This is athetosis of the hand.
Linda is exhibiting Parkinson's disease. This is caused by a lesion of the substantia nigra, which is basal ganglia. This is caused by a loss of dopaminergic input from substantia nigra to the caudate and putamen. This is characterized by rigidity, tremor, and akinesia.
To recap the abnormalities in the basal ganglia,